evaluate the integral from -1 to 2 of x cubed minus 2x dx. Now, if we want to be able to use the fundamental theorem of calculus, we will need our function to be continuous on the interval from -1 to 2. And it's a polynomial, so we know that that's the case. So we've got no continuity problems. So that means we can antidifferentiate and use the fundamental theorem of calculus, part 2. So if we look at this one term at a time, because remember, we had a property of integrals that said that if we had a difference or a sum of two terms inside an integral, we could integrate term by term and just take the difference. So the antiderivative of x cubed is x to the 4th over 4. And then minus, well, the antiderivative of x is x squared over 2. But if we're dividing by 2 and multiplying by 2, those cancel out. So we just get x squared. And we know, of course, that x squared is the antiderivative of 2x. Not difficult at all. We've seen that before. And then we have to evaluate this at -1 and 2. So first we'll evaluate this at 2. It's going to be 2 to the 4th over 4 minus 2 squared. Then we have to subtract what we get when we evaluate this at -1. So -1 to the 4th over 4 minus -1 squared. All right, if we look in the first one, 2 to the 4th is 16. 16 divided by 4 is 4. So we've got 4 minus another 4. 2 squared is 4. And then in the second one, -1 to the 4th is +1. So this is going to be 1/4 minus. And -1 squared is +1, but we still have that subtraction there. So it's going to be 1/4 minus 1. Now 4 minus 4 is 0. And 1/4 minus 1 is -3/4. And when we're subtracting a negative, it's the same as adding. So that is 0 plus 3/4, which is 3/4. So that is the value of that integral.